Hello. Today we'll be discussing some more topics in section 2.1. This will be a supplemental video. There will be no check on learning for this video. Today it'll be perpendicular parameterization, midpoint, point direction, and 2-point equation forms. So first thing first is perpendicular. What does that mean? We discussed previously that perpendicular is a line or array that has a quarter turn. So how do we represent this as vectors? And we'll explore this concept in this video. But first, we have to be able to make a line and how to do that. Well, if I was to give just coordinate and I have a line, what we can do is describe this line, or at least part of this line, by saying if I was to start here and end here, and I'm going in that direction, how can I parameterize this? How can I make an equation out of this? And so what we can do is that the vector xy, think of this as x being the change of x, y being the change of y. Well, we want to be able to describe this with the use of a single variable. And so we're going to say 1 minus t, and we're going to times this by x naught, y naught, plus t times x1, y1. What is this? Well, this point here I'm going to label as x naught, y naught. And this point here I'm going to label as x1, y1. So as my t, you can think of my t being somewhere between 0 and 1. If I'm at 0t, so I'm plugging in a 0 here and a 0 here, this becomes a 0 vector, so it goes away, and I'm left with just x naught, y naught, meaning that I'm starting here. And as t goes to 1, this will go to 0. So it'll go away, and I'm left with 1 times x1. Well, that's just x1, so that means I've made the journey to the x coordinate that I desired. Similarly with the y, I can now see that I start at y naught when t is 0, and when t is 1, this goes to 0, this is 1, so I end at y1. So I made my journey through the y direction. So when I put those two together, I make my journey from my starting point, my ending point. So this is how I can parameterize a vector. Another useful thing is maybe finding the midpoint. What is this point here on the vector? Well, this is where we can use the fact that it's an oriented line segment, meaning it doesn't matter which direction I kind of go to the midpoint as far as trying to find where the midpoint exists. So I can use this as a line segment. And so I can just go, okay, well, x mid is 1/2 x1 plus x naught, and y mid is 1/2 y1 plus y naught. In other words, I'm finding the average of my x1, x naught, my average of my y naught, y1, and that's how I can get the midpoint. And so now I get my midpoint, and I can describe a vector from a starting point to the midpoint. Come. So now we're going to introduce a directional vector. So and what a direction vector does is we're going to label it D and have it be H, K. And this originates from the equation, or it gives rise to the equation x or k times x minus x naught equaling h times y minus y naught. Essentially what this means is that if I have a vector that's saying that this is the direction that the line is going, then what I have here is this is basically symbolizing a change of x. And so however far my x is, well, it's going to be proportional to what my other change is. And so if I rearrange this a little bit, so say if I divide by h on each side and divide by k on each side, I have x minus x naught all over h is equal to y minus y naught all over k. Remember how I've been stressing that I can think of this as change of x, or the first entry is change of x, the second entry is change of y. Well, what's the change of x divided by the change of x? 1. What's the change of y divided by the change of y? 1. And so here, I'm just basically saying that these proportions have to match up. Whatever my change of x here has to match my change of x here times my change of y. Change of y times change of x. Change of y times change of x. That's all it is. And this gives rise to the point direction equation. That's what this is. So this is the point direction equation. So then the other way I could describe a line with vectors is y1 minus y naught x minus x naught is equal to x1 minus x naught times y minus y naught. Now, this is called the 2-point equation. Now, for this, it's essentially this. All that we have is a point with a change of y times a generic change of x, and a specific change of x times a generic change of y. That's exactly what this equation is. Just in the first one with the point direction equation, I'm given a directional vector, and I just have to split it up, put it in the equation. Here I'm given 2 points. Well, those 2 points form a vector. A vector has direction, thus it's a directional vector on that line. And now I can just insert it into my equation. So I can almost think of this as the k and this as the h. And we get the exact same equation. Okay, the last things I want to cover real quick is that if a line is given in standard form, ax plus by is equal to c, we can still extrapolate a directional vector because we can say, hey, my direction vector is equal to negative b a. Now, you might look at this and go, that's crazy. How do I do that? Well, remember, I've been stressing that we have the change of x, change of y. Let's rearrange these variables real quick. I can rewrite this as y is equal to, I have c divided by b minus a divided by b x. I'm just subtracting ax to the other side, and then I divide by b, assuming b is not 0. And what we get here is we don't care about the starting point. We care about the change of x and the rise over run, the change of y, the change of x. And so this is a negative, so I can just throw this negative either in the numerator or the denominator. I just chose one. So let's choose that. And we get negative b being the change of x and a being the change of y. And it might be like, wait, what if I times by -1 to the top and bottom, and I have that? Well, guess what? We can take out a negative and we get b negative a, and we have a negative out front. Well, this negative is just describing a vector going in the other direction. So this directional vector, because we're on a line, it's going off in infinity in both ways. I've just described the vector going the other direction. And that's okay. But so now what if I want a vector, if I have, say, a line there, I want it to be parallel. I want to describe what this line would look like. This is perpendicular. So I want to try to describe that. Well, the perpendicular vector is equal to a b in the notation of standard form line equation. And this would be a perpendicular vector, or we could also call it a normal vector. And so that's describing a vector that is perpendicular on the line. Now again, we don't really care about the direction because if I attached a negative a and a negative b there, well, now my vector flips and it's still perpendicular, but now going the other direction. Yeah, with that, this concludes the little mini talk and just covering up other topics I didn't quite get to in section 2.1. So thank you for watching and have a great day.